the instructions are answer questions about Microsoft Semantic Kernel SDK using MCP. And then we're asking it here, how do I make a chat completion call using Semantic Kernel and OpenAI? So I'll just run this quickly.
Hello, everyone. We are back at Open at Microsoft with Evan. Hey, Evan. And
Hello.
Today we're going to deep dive, Evan. We had the first video that we remember that we discussed about building AI agents workflows with Semantic Kernel. You can watch. I'm going to give you the link here as well. Please watch that video. It was amazing. We got a lot of attention there. And Evan, people ask me about MCP, and that's why I invite you back here to deep dive a little bit on MCP and explain how you can use Python and MCP specifically to integrate MCP on those agents, on those workflows, on those processes that we described on the first video. How that sounds?
Yep, sounds wonderful. So great to be back with you. Thank you for having me. Hello, everybody. So let's talk about Model Context Protocol, MCP. And just to set the stage, we're going to kind of talk high level, and then we'll dig deeper down into it and how we actually use MCP within Semantic Kernel itself. So MCP is a vendor agnostic, universal language for tools and AI models. So it's standardizing how models discover and can use these tools dynamically. And an MCP server, which is part of this, MCP architecture, is able to advertise what tools are available, and the client, the MCP client, can then instantly use them without having to hard code anything. So I think that's one of the great parts. It's using this standard protocol. It's any vendor, so you're not locking yourself into any particular vendor, and then you get this instant interoperability, and so you can get started really quickly. And it's a great way to add intelligence to your agents, grounding these extra tool calls. And so many people now are creating MCP servers. And with a couple lines of code, you can add this robust tool calling capability to your agents, as we will show in a little bit. So
yeah, that's a good point. Like, a few years back, you probably remember we had like the API economy, where everybody started building APIs to be able to communicate with third-party systems and so on.
Right.
And how that changing now with MCP is kind of, in my view, now we're not talking directly with the APIs. It's the large language models that are figuring out how to talk with those new APIs, let's say, that we call MCP servers now.
Right. Yeah, so I think the cool thing is, if if you have your microservices, you have your APIs, and now you want to integrate them with large language models, you can do that in kind of a really easy way. I mean, you can wrap essentially a service, provide this now in this, this standardized schema, and you're kind of reducing adapter churn, you're reducing, the need to create these custom plugins and such. Now you're just able to advertise. People can consume those with whatever model they're using because it's standardized. You're getting this JSON schema that you're eventually sending back to the model for tool calling. And it kind of, it helps keep permissions clean. And companies can actually just start small and wrap a very small API or something. And because APIs are so prevalent, and we've seen that now with this giant lists of MCP servers available. And so I think that's really a big plus. And then from the client side, we basically just take a URI. We're getting a URI. Maybe there's some authentication or some arguments depending on the type of MCP, transport that we're using. And the client is then, asking, okay, what do you have available? And then as a server, you can add new MCP tools, advertise them, and the next time I call up to load the tools, I get those tools back. And so again, I'm not hard coding things. I'm not creating kind of brittleness in my code, which is really nice. That dynamic nature is really important. And it just kind of allows, it's opening the door for anybody to start to create these useful tools. And I'm seeing really cool things, MCP servers from NASA, and you can start to ask about, what asteroids are we going to see, or comets are going to be approaching, or things like GitHub that I'm sure everybody's is aware of, or Microsoft Learn site, which we're going to look at in the demo in a little bit. It's just, I think it's a great way, and it's a wonderful protocol that's made its way, into this AI universe, and it's such a strong point.
That's amazing. That's exactly how I see that. I see on this diagram here on the screen that we discussed on the first video, how that fits that conversation that we just had here, that the agent in the middle is going to be calling those tools.
Yep.
And we're going to show that on your demo. And
exactly.
how that communication there, how that dynamic thing happens there.
Yep. So when you create an agent, so we kind of looked at this very briefly in this last video, showed a few lines of code about what it means to create an agent in Semantic Kernel. And then now with the tool, we'll show you here in just a few minutes of what that looks like in code. But in that lower box around tool calls, it says retrievable actions memory. We've just opened the door with this new MCPStdioPlugin, or Streamable or WebSocket, and hitting that MCP server. And we in Semantic Kernel abstract so much of the kind of the heavy lifting away from the developer. And so we'll make the call to get whatever functions are available, prompt functions, APIs, whatever it may be. We'll wrap them in the Semantic Kernel abstractions. So they're turning into kernel functions. And then when it comes time to call the model, we will form the JSON schema that needs to be sent to the model that it expects from that MCP protocol. And the model then has that context, and you've just enriched your experience talking to the model, and not just a chatbot anymore. Hey, how's it going? What's the weather like here? Or how are you doing today? Help me with this math problem. Now it's using this MCP server context and saying, oh, I can answer questions about docs for you. I can make this API call for you without us even having to write a huge amount of code. We're able to focus on our business application. We're able to focus on our agent, our process, whatever it may be that you're building. And again, Semantic Kernel is doing that heavy lifting for you. That's the beauty of the SDK. You don't have to worry about all the deep down nuts and bolts. We want to just make sure you can build and leverage that in your business as you work on your AI applications. So
that sounds great. Do you want to show? Maybe you can show that JSON that you just showed me a few minutes ago. You showed me that JSON with. Let me share your screen here.
Yes. And so as we walk through these code demos quickly, we're gonna cover a few types of transport options that are available in Semantic Kernel. And so this first one, all these samples are available in our repo today. We'll give a link out and so that you can go and explore these on your own. But again, we're diving into a Semantic Kernel concept sample, which is using an MCP StreamableHTTP plugin. So this is one of 4 MCP plugins we offer. And this particular one, we're giving it a name and a description. It's very simple. And actually, it's called GitHub plugin here. It could be Learn Microsoft, but we're then giving it a URL. And this is the Microsoft Learn site MCP server. Doesn't require any auth right now. And once you wrap it in these few lines of code, you've now then turned it into a Semantic Kernel plugin, which means it's a kernel function. And as I said earlier, it gets turned into the JSON schema. So we're really just adding it in this line. And again, we're not requiring you to figure out what the transport is like underneath and all that protocol and what is it like to form the payload. All that is done for you. And when we actually run and get the response, we are able to query about Semantic Kernel SDK. And so, George, as you said, what is that kind of schema looking like that we're sending to the model so it has the context? This is the JSON schema. And so it's a well-known JSON schema.
I think the question that many people ask for us is how that magic works, how the model knows how to, call those functions and how to pass those parameters on our behalf. And that's
Sure.
something you can explain how that works here.
Yeah, it's a great question. So the magic really is just represented in this JSON schema. So this is all part of the payload you're sending to the model. The model's expecting a model ID. It's expecting some messages, perhaps. It's expecting some other settings, like how many tokens you want to use. With new reasoning models, it may be low, medium, high reasoning. And then you can provide tools. And so as a developer, you can specify auto function calling. You can specify a must call this particular tool, or don't even call any tool, even though you have information. And so with auto function calling, the models have been trained to use these tools and derive the context from the information we give them. And we're turning this natural language JSON that you see on the screen into tokens. There's embeddings involved, and it's ideally at its lowest level, it's math. And so we're giving this information, and the model knows if I have a question about fetching a particular Microsoft doc or searching a document, it says, oh, I have a tool for that. And now it's leveraging this JSON, and it's going to call back to Semantic Kernel with a tool call that we invoke to the MCP server, or the function. And now you're off and running. And all this stuff again is handled deep down without your worry or anything about that. And so I think it's a really cool way to kind of peek under the covers, so to speak, and see what this actual payload is, because we can see when this function is called, the model knows it has to have a URL in the context. So if I'm asking, please give me information about Semantic Kernel, if it doesn't have the URL, it'll get it either via the user asking it or from some other previous part of your history. It's very good at extracting that context, but it knows what's required and what's not, even giving it enums or other things, so it knows what values to select. It's just gotten so good now, and the interaction between the user and the AI model is becoming more seamless.
And Evan, another question that people ask is, when they compare MCP server with an API, is that API can break the API. Let's say API version 2, we could have a break change on the API. That means that the client has to change the code. And that doesn't happens on MCP servers exactly because they are dynamic.
Right.
And that's the beauty of building with MCP servers, is that they are completely dynamic. They're not going to break your code if there's a new version of the server, because then now they're going to figure out how to call. And also, you told me like the models are getting better on those function calls. Each new model that's getting better is smarter how to select the right one.
Yep.
I think it makes a lot of difference there. Let's see the
Definitely.
code. Let's see your demo. We're going to see that.
Yeah, of course. So what we're doing, just asking a super simple question. The instructions are answer questions about Microsoft Semantic Kernel SDK using MCP. And then we're asking it here, how do I make a chat completion call using Semantic Kernel and OpenAI? So just run this quickly. It's going to spin up the the plugin, the MCP plugin. It's going to create the agent. And on the screen here, within a couple of seconds, we are going to see a response about some information of making a chat completion call with our tool. So it says, how do I make a chat completion call? And now we can see that we got a response back, some pretty lengthy markdown, which is interesting. And so if I were actually going to paste this somewhere, it would format the code properly, telling you need some certain environment variables, use these imports, add the service. And even at the bottom, it says, here's some references. So a great thing is to be able to get this information from the model, but sometimes we think, is that actually accurate? Is it true? And now when you start to get annotations and references, and you can go and look at it and say, oh, that is true, that is right. The whole grounding aspect is I think a conversation we probably could have in another video, which is, I think is very important. So this is one particular example using.
You mean they leveraging information from the Microsoft documentation
exactly.
Microsoft Learn
Yeah. So we just
to do the
programmatically went. Yeah, we just programmatically went and searched Microsoft Learn for semantic kernel. It extracted information from the live documents, told us code that we need to write to get going. So you can imagine how this jump starts somebody's learning and get going, as they're ramping up on something. These tools are getting so much more powerful.
Yeah, that used to do before MCP servers. We used to do that with RAG or something that we could augment with company information. And now, like if you have a company and you build your MCP server with your specific documentation, and you make like with a few lines of code, like Python code, you can just call that, and
Yeah,
that's more dynamic. They just get like a PDF file and attaching as a context for the model.
right.
And that's, I think, the big difference from MCP and then RAG and other things.
Definitely. So in this second sample, it's just a different transport style from Semantic Kernel. It's called MCPStdioPlugin, so standard input output. This allows us to run and hit a different MCP server. So this one is actually going to be GitHub. And it's going to use a GitHub personal access token. So if you're going to run this for yourself, you want to make sure you have an access token you generate from your GitHub account. It has the proper scope and so on and so forth. But this one is going to use Docker, and it's going to run with these particular arguments. And so it's hitting the GitHub MCP server. Really simple question. What are the latest 5 Python issues in Microsoft Semantic Kernel? You can imagine how you could extrapolate this to other use cases to actually maybe review PRs or automatically comment on discussions or have AI work into your workflow in that way. But again, we're creating this plugin again, just as we were previously. So the syntax looks similar, a little bit different with the args, and then passing that into the chat completion agent. And so when we run this one, it's going to do the same thing. We're loading the plugin based on what's available from the MCP server. We're then creating the agent, and the agent then broadcasts that information to the model. The model has that context when it's answering the questions. It's not going to know what the 5 Python issues were. It was not trained on that data, right? And so we can see now one of the latest ones is semantic kernel equivalent to model retry. We're getting things created when we're filming this video today. And so we're able to see and get information about this. I can then have another step in my process go and actually do some action on this. But again, in a few lines of code, we're now communicating with MCP servers and leveraging that really useful tool call.
Yeah, that's great. And because Semantic Kernel is also only helping with MCP, they help you also with the whole steps of your workflow. You can see that on the first video, and all the process and memory and all these other things that you don't only have to think about your logic pretty much. That's what I really like on that. The whole things, the whole framework, not just one MCP integration there.
Yes. And I think the last call out I want to do, so I just want to show, we've been showing chat completion agents. These are agents hitting AI services. We have a semantic kernel agent called the Azure AI agent. And this is an agent that allows you to interface with a Foundry project or a Foundry agent that you may create in the server. You can pull the agent down in code and run it. You can create an agent in code, and that exists because it has a server-side definition on the server. The threads and messages are server-side managed, and so you have that ability to then pull down a conversation. That's the way that information can get persisted in that way. So I just wanted to show really quickly, if I was to use an MCP tool with an Azure AI agent, again, it just takes a couple lines of code. You can definitely still use Semantic Kernel's MCP plugins with this. This has a different flavor, just their own type. Azure SDK's type is MCP tool. And we're just able to give it, again, a label, a URL, and we can actually specify what tools does the server have the ability to call. They allow for an MCP approval mode, and then we're passing that into the definition, creating the agent. And just like before, we're then able to invoke the agent, start to ask questions, and leverage that particular tool in this way. And so I just wanted to call this out, that this is available now in Semantic Kernel Python, I think as of 1.35.0. And it's a really useful way. Again, if you want to just get started with MCP, use the tool with Foundry agents. Really powerful, again, to get interfacing with these MCP servers. We see so many produced, so many great use cases, and businesses leveraging these as part of their workflows. And it's just such a powerful way to enrich your AI application.
Yeah, that's a good way. There's a lot of Microsoft customers using, Azure AI Foundry, and they wanted that integration. And sometimes they ask us, how can I write the code? Yes, you can. You can write your logic, and in a separate way. You have developers on your team. And by the way, like if you're not following in the Semantic Kernel project, that's the URL. And please make sure that you if you like the project, leave a star, give a like for us. And also, we have a link for the Open at Microsoft show, so you can follow. And if you you are maintainer of a project on AI or anything related with technology, and you wanna show that here on the show, send us your submission for your talk, and we are glad to talk to you and see if we can create an episode on your project. And don't forget the first video. Let's go back on the first video here, that you can watch as before you watching this one here. And make sure that you subscribe to Microsoft Developer Channel and follow us. Thanks again, Evan. I think was a good deep dive on MCP using Semantic Kernel and Python. And maybe we come back for another one soon. Thanks a lot.
So really appreciate you having me. Thank you.